Okay, we're going to be looking at the Lesson 5 assignment, very first assignment of Lesson 5, which is an understanding of what some of these shapes mean and what some of these shapes can be labeled, okay? So we are talking about points, lines, and planes. And our first figure here is comprised of a plane with a line laying across it and a line going through it. 4 points on the line, 4 points on the plane. The name of the plane is C, and the name of the line going through the plane is M. Okay? So the first question says, what are two other ways to name the line EF? To name the line EF. So this is the line EF. And there's definitely more than one way we can name this line. So when we're looking at EF, we want to think about all the points that are on this line that I could possibly use to name it. And remember, we talked about you can name a line using 2 points on that line. So I can name this line EB because I can use any 2 points. So I could name this line EB. And remember, notation would tell me to put the little line above it with the arrows on it. I could name this line BF. And I could have done the opposite as well, right? This could be FE, this could be FB, this could be BE. So I can, because it's a line, I can name it in either order. Number 2 says, what are two other ways to name plane C? So here's plane C. You can see here the whole plane. And so we name a plane with 3 letters not on the same line. 3 letters not on the same line, or 3 points not on the same line. This particular plane has 4 points that we can see, E, G, B, and F. So I want to do any 3 of these points so long as they're not E, B, and F, because those are all on the same line. So I can do E, G, B as one of them. EGB, and I don't have to put a little line above it because it's a plane. I could do EGF, and these could be in any order. I could do BGF. I could do FBG. I could do any variation of these 4 points so long as it's not E, B, and F, because they can't all be on the same line. Number 3 says name 3 collinear points. So remember, collinear points means on the same line. So remember, co means together. So we have points together on the same line. So if I look at this, here's my line, right? So I have E, B, and F. And remember, they're points, so I'm going to separate them by commas. E, B, and, F. Here we go. If I want 4 coplanar points, this is points that are together on the same plane, points together on the same plane. So I'm looking at E, G, B, and F. C is not a point because it doesn't have a physical point next to it. That's how I would know it were a point. E, G, B, and F. And because I'm naming points, I'm going to separate by commas. E, B, F, and G. So there's my 4 coplanar points. All right, looking at number 5, numbers 5 through 8, I'm using this line over here with the 4 points on it, 4 collinear points, and I'm wanting to name all the segments. So the easiest way to name the segments here is start on R and just start naming them from R to the next point. So the first one I see here would be RS. And the next one I see here would be RT. And the next one would be RW. Okay, so RS, RT, RW. And then I go to the very next point. So I'm kind of like chopping this off and just starting with S, and I see ST, and I see SW, and then I go to the very next point. Remember, I'm just kind of chopping this part off now, and I have now TW. And these are all of my line segments. Now, we can make each one of these segments a ray simply by putting an arrow. So instead of chopping it off at the point, we think about actually chopping it off here, and then it can go on forever, right? So each segment can become a ray. So if I put them in this order, I read this direction. So technically, I can make all of these rays because they can just keep going. And really, RS, RT, RW, they're all going to end up being the same ray because they all start at the same place and go in the same direction. So I could have ray RS, ray RT, ray RW. So I'm just making my segments here rays. Ray ST, ray SW, and ray TW. All right. And then that's really only my rays that are going down, but this line actually goes up as well. So I have to also consider all of the ones that would go this direction. So if I start with W, I could have WT, which if you notice here is just really, these are just switched, right? This is the ray that goes down, this is the ray that goes up. And then I would have like WS, WR, and then I could leave W and go to a different endpoint, and I could do S or TS. I could do TR. And then I go to this endpoint, right? So here's a ray, and this ray would be SR. Get rid of all of that stuff so I can make notes in a second. All right. Number 7 says, name the pair of opposite rays with endpoint T. Name the pair of opposite rays with endpoint T. So here's endpoint T, right here. And I want to make opposite rays, which means I got to start at T and go in opposite directions. So I'm going to go this way for one of them. So that's going to be T to S, so that will be the ray TS. And then I'm going to go this one for the opposite one, so that would be T to W. So that would be the ray TW. Notice how my opposite pairs are both starting with the same letter because they have the same endpoint or starting point, however you want to think about that. Okay. Then it says, name another pair of opposite rays. So really, I could go and start at S instead of starting at T. And I could say, okay, well, I've got this ray that goes from S to R. And I've got this ray that goes from S to T. And those will also be opposite rays. Remember, opposite rays, same starting point, opposite direction. Okay? Moving on to number 9. Number 9 says, name the intersection of planes ABC and BCG. The intersection of planes for ABC and BCG. All right. So here's kind of how we want to think about this. And I may have to pull in another sheet of paper here in a minute. But if I want to think about what does plane ABC look like? Okay, so ABC. Well, here's A, and here's B, and here's C. And remember we talked about when I do this, I really want to have a quadrilateral. I want to have a four-sided figure. So I need a fourth point that would be on this plane. So my fourth point that would be on the bottom of this box, like all these 3 other points, would be D. All right? So here's my plane that's ABCD. And if I kind of shaded that plane in, it would look something like that. Okay? Then I have a plane that is BCG. So here's B, here's C, and here's G. So this plane is this side of the box. So the fourth point I see on that plane would be point F. Okay, so I'm talking about this figure right here. And these two planes meet at a line. Postulate 1-3 says that if two planes intersect, they intersect at a line, right? So when we're looking for the intersection of two planes, we're always looking for a line. So I hope you can see this. These two planes meet right here at the line that is BC. And notice my notation here. I'm making sure to put that line with the arrow above it. All right, I'm looking for the intersection of planes for HF, and I am looking for it to intersect GFC. So I'm going to do the same thing, and I'm looking for the intersection of EF and H. EF and H. So here's E, and here's H, and here's F. Okay, so you can see these 3 points are on the top of the box. So the plane I'm going to be talking about this time is actually the top of the box. I'm going to make it in yellow this time so we can see a difference here. So here is the top. And then GFC. GFC, here's G, here's F, and here's C. So G, F, and C are the side of the box again, and they share with B. So this time I'm talking about this right here. So I hope you can see the top and the right-hand side share this line right here. And that is the line FG. And I need to put little arrows on the end so that we understand that it's a full line. All right, the next question says, name two planes that intersect at line AE. So this time I gave you the line, and I want you to find for me the two planes. So let me get a clean homework paper here so that I can get one that hasn't been drawn all over. I'm just going to pull this in really fast. Okay, so here's what I'm looking for. AE is right here, right? So I need a plane where this is the side of it. I need a plane where this line is included in it. So that is definitely the front, right? So if I were to shade from that line, you could see that I would be shading the front of this box. Well, I don't know how good I did on shading the front, but the front. And then a little harder to see, maybe, is the other part is off to the side, right? So this left-hand side and the front of the box. So if I want to name the front of this box, I use any three of the letters on the plane. So how about E, A, B? And the side, I use any three letters again. So how about E, A, D? Right, notice how my line is included in the name of my plane. All right, and then we're going to do one more with this picture. It says name two planes that intersect at HD. And HD is this back one right here. So we don't want the front anymore, but we actually still want this side. I hope you can see that. This whole side is included in, or this line is included on that plane. And then also the back, right? So the back of this box also includes that line that is HD. So the left side, which we already wrote, was EAD, but if you wanted to include the letters, you could call it HDA or EHD, So here about that, I'll do EHD and the back of it, which would be GHD. All right. I hope that helps. All right. So number 13, moving on to number 13. It says use the figure to shade the plane that contains the given planes. Oh gosh, contains the given. How about points? I didn't even notice that today. So BFG. So we're going to do the same thing here. BFG. 3 points on this plane that is the side of the box. So find the fourth point in the plane, connect the 4 points, and then shade. Pretty easy on that. So it's easy when it's the side of the box, less easy when it cuts through the box. So in this one, we have E, H, and C. So this seems strange, right? Because we have these, but then if I connect these two, I'm going through the middle of the box. So basically you want to think about if it goes from front to back on the left side, it has to go from front to back on the right side. Okay? And then you can sort of see I can just connect here. And so my plane goes through the middle of the box like this. All right. Number 15, DEF. So I find D, I find E, and I find F. So you can see I have 2 in the front, and then I've got to connect to the back, which means this one also has to connect to the back. So C is actually my fourth point in this plane that goes through the middle again. Okay, moving on. So these directions say, if possible, draw a figure to fit each description, otherwise write not possible. So 4 points that are collinear. So collinear means 4 points on the same line. So that's, you've got lines that are all lines have an infinite number of points. So of course we can have 4 points that are on the same line. 17 says 2 points that are non-collinear. So here's the issue with this. You might be tempted to draw a line with a point on it and then put another point down here, right? And say, oh, well, they're non-collinear. Well, I can draw a line between them. So actually they are collinear. So this is actually a postulate that says if you've got 2 points, there is exactly one line that has to go through them. So this one actually is not possible because I can take any 2 points that you draw and I can draw a line between them. So they have to be collinear. So this one is not possible. Number 18, 3 points that are non-collinear. So again, you're going to be tempted to say, oh, I can do that. Here's A and B. And then here's C. And in this case, it is actually true, right? Because if I connect AC, B isn't on it. If I collect CB, A isn't on it. So there is actually a way to draw 3 points that are non-collinear. Could I draw 3 points that were collinear? Of course. C were on the line. 13, 3 points that are non-coplanar. And so this is actually also a postulate, right? The postulate says any given 3 points, you can make a plane go through them. So there is a postulate that says I can contain 3 points on a plane no matter where they are. So this one is also not possible. The next one says a figure with points B, C, D, E, F, and G that shows lines CD, BG, and EF with one of the points on all 3 figures. Okay, so we have a line that is CD, we have a line that is EF, and we have a line that is BG, and somehow we want to have a point that's on every single line. Okay, so let's see if I can make the point be B. Okay, so here is BG. And here is, what do I want? CD, CD, and EF. Here is EF. So let's see if I did a good job. A figure, yes. With points. B, yes. C, yes. D, yes. E, yes. F, yes. G, yes. That shows 3 lines. Line CD, I have one of those. Line BG, I have one of those. Line EF, I have one of those. With one of the points on all 3 lines. And B is on all 3 lines. Number 21, a ray that contains another ray, but they're not the same. Okay, so how about this? Here is ray EF, and here is ray AF. And AF and EF are not the same ray because they don't have the same starting point. Number 22, 2 distinct lines that intersect at more than one point. We know lines have to be straight, and there's a postulate that says that they can only intersect at one point, so this one is also not possible. Right? The only way to do that would be if it bended, right? But this is not a line because it's not straight. All right, just 3 more, and they're pretty quick. So it says graph the points and state whether they are collinear or on the same line. So we have point 1, 1. We have the point 4, 4. We have the point -3, -3. And if we get a ruler, we could maybe convince ourselves that they are all on the same line. But we would want to check the slope between them just to make sure they're actually on a straight line. So this slope would be 1, 2, 3, 4. 1, 2, 3, 4. 4 divided by 4 is 1. And this slope would be 1, 2, 3 over 1, 2, 3. And so that slope is also 1 because 3 divided by 3 is 1. And so these are collinear. All right. Next one, we have a point at 0, 0, also known as the origin. We have a point at -5, +1. We have a point at 6, -2. And so if we try to draw a straight line between these, let's say I'm just going to pick 2 here. Let's say I pick these 2, right, to make sure that that one's on it. Looks like this point is probably not on that line. And so these are not collinear, but I could check the slope if I wanted to. My rise would be run, and my run would be 5, right? So this would actually be -1/5. Remember, it's decreasing. And then right here, my rise would be -2, and my run would be 6, which is -1/3. Notice the slope isn't the same between of them, so these are not collinear. All right, one more. -2, -6. There's my first point. 1, -2. There's my next point. 4, 1. There's my next point. Looks like it might be collinear if I draw a line between the, let's say, these 2 right here. This is kind of a struggle here. So let's see. Oh, it looks like we're not going to hit that point, but we can check with slope to see if it actually does. So this is 1, 2, 3, 4, and this is 1, 2, 3. So the slope is 4/3. And if I check this one, 1, 2, 3 over 1, 2, 3, this actually has a slope of 1, right? Because 3 divided by 3 is 1. And so not the same slope means not on the same line. So these are also not collinear. All right, guys, I hope that helps you with this homework. Good luck.